Hello, everyone. Thank you for attending today's webinar titled Automating a Manual Liquid Coating System, brought to you by Products Finishing and presented by Nordson and Pneu-Mech. I'm your moderator, Scott Francis, editor of Products Finishing. Today's presentation will last about 40 minutes and will discuss identifying opportunities for automation in your plant. A question and answer session with a panel of experts will follow the presentation. If you have a question, you can type it at any time during the webinar in the question field of your GoToWebinar control panel. The webinar is being recorded and when complete will be made available to you via email from Products Finishing. Our presenters today are Mike Lebovi, Product Portfolio Manager for Nordson, and Kayla Burke, Account Representative for Pneu-Mech Systems Manufacturing Incorporated. I believe Mike is up first. Mike, I'll hand it over to you.
Thank you, Scott. As Scott mentioned, my name is Mike Lebovi. I am the product manager for Nordson's liquid product line. I am joined today by other Nordson colleagues, Jim Atkins and Brian Parker, who work directly with a lot of our customers on these various projects that will be able to answer some more in-depth questions at the end of this presentation. We also have Kayla Burke and Jason Gatton, who are trusted integration partners at Pneu-Mech Systems, to give us a little bit of insight on what goes into some of the infrastructure considerations for these projects. So looking ahead at the agenda for today, we'll start by reviewing some of the different types of automations and the ways to implement. There's a lot of new technology entering this space every day, and when people generally think of automation, their mind goes straight to those high-tech robot solutions. But there are a wide range of solutions that go between a manual and robotic systems. So our goal today really isn't going to show all of those options, but it's really to start discussing some of the considerations you might want to start thinking about as you plan for automations. Some of these will be obvious and some of these may not be as obvious. Then we're going to conclude the presentation by walking you through the processes and steps that you'll need to take to hopefully achieve your automation goals. So moving into a first topic, let's take a look at some of the different types of automation. I'm sure everyone out there has heard terms like factory of the future, machine-to-machine learning, industry 4.0, IoT, which is the industrial Internet of Things. And even though these names may be different, the core idea is really the same: how to reduce downtime, optimize performance, streamline maintenance, and ultimately improve decision-making by using both historical and real-time data. This technology is here, and as an example of what it's starting to look like, Nordson's Wisdom Smart Connected Platform is a cloud-based application that can give you an array of information anywhere, anytime. This type of technology requires your equipment to communicate to not only other equipment in your factory, but also to other higher-level systems to generate automatic reports. Some things that you really should start to consider when looking at this type of technology is, do I have an IT team to support this type of communication network? There are a lot of different type of communication protocols that equipment will need to communicate with, and having a deep understanding of what it's going to take and the different types of communication is going to be critical for this type of technology. Do I want to take the responsibility of creating these dashboards on my own, or do I want to partner with a company to do this for me? Several of our customers want the information up to their systems, but once they get it there, they're not exactly sure what type of reports to generate. In this case, you can partner with a firm that will be able to generate these reports for you. And if that's the case, what steps are you going to do to protect your information from being compromised? There's no shortage of hackers out there these days, so understanding how you're going to secure your information is going to be critical to implement this type of technology. So let's talk about paint robots. Robots are traditionally used in high volume tier 1 automotive and OEM applications, where there's a small variation from part to part. A critical thing here is that the parts will need to be presented to the robot in the same way each time. This can be a benefit or a challenge, really depending on the application. The benefit here is that it gives you flexibility and you could reduce your setup time from one part to another. But this can be a challenge. Being able to place the parts in the fixture the exact same way every time really depends on the complexity of your parts and how they're loaded onto the fixtures based on the preceding processes. The more variation between parts, the more programming that's going to be required. You may be able to simply modify or tweak the program if the part is similar to an existing one, but if the part is drastically different, this may require an entirely new program. To do this, you're typically going to need a robotic technician on site. Like anything, the more your team familiarizes themselves with the robot, the faster they'll be able to come at programming. But you may need to anticipate a sharp learning curve at the beginning as you ramp up into production. Otherwise, you may need to consider outsourcing this type of service as the rest of your team gets up to speed. Another thing to consider with robots is that they can be dangerous. They can move in any direction at any given time. So it's not always obvious where they're going to move next. In these applications, it's almost certain that you're going to need to install additional safety guards, such as light curtains, switches, and in most cases, even full cages to keep people out altogether. Stepping down from robots, you then have a wide range of options. Automation can be as simple as adding a part mover to an existing manual application. You can spin the parts, move them up and down along a conveyor with fixed guns, and even spin the parts as they move along the conveyor. Any device that lessens the amount of human interaction or reduces the pain or movements is a step into automation. Then there are gun movers, such as oscillators and reciprocators that moved at a fixed stroke distance and speeds. A step up from there may be a smart reciprocator capable of changing speeds and stroke lengths depending on the part that's being painted. This will also require a level of programming, but is usually done with simple PLC code versus requiring a robotic engineer. Even the way that you orient the spray devices on the mover will be critical. In the second image, if you want to increase the line speed, you may need to mount several devices side by side, giving the part more dwell time or coding time as the part moves through the line. In the third image, it may make sense to stack your spray devices in 2 zones and then load 2 parts on the same rack. This will allow you to paint twice as many parts at the same line speed, keeping the overall booth footprint the same. And then there are hybrid lines that combine manual and gun movers in the same booth. This is more typical in applications with hard to spray areas with deep recesses that may need some more attention in those critical areas. This is a really good option for those of you who may want to gradually upgrade into automation over time versus installing an entire new finishing system. So what are some of the other factors we should consider? How much downtime do I have per day? When thinking of downtime, the obvious thought is how much time is spent repairing something that is broken. But are you also tracking how long it takes to prep the system, to change from one paint to another, or even the time to verify the coating material meets the specification? Routine tasks such as manually checking material temperature or viscosity is time that could be saved using various automation tools. Speaking of those routine manual inspections, how accurate are they? Are they preventing errors? Are your operators from shift to shift following the same processes and interpreting those measurements the same way every time? Does the temperature or humidity in your plant change based on the time or day or during different seasons throughout the year? Installing automated monitoring and controlling devices, even into a manual process, can greatly improve your overall quality. One of the concerns people have with automation is that it's going to replace jobs, impacting workforce. But let's be honest, it's becoming harder to find experienced workers willing to stay in the same position for an extended period of time. Many experienced finishing employees are retiring or finding new careers, and the cost associated to training new hires is increasing. If you are continuously training new operators, you may want to consider what it will take to automate that process. Is there a need to increase production? Instead of turning on additional shifts, you can coat more parts in the same amount of time. In the example from earlier, even the way you stack parts could double, triple your production output using the same footprint and same line speeds. When it comes to safety, did you have to decrease the number of workers due to COVID? Even essential businesses had to implement social distancing and other safety protocols to keep employees safe. And with healthcare costs rising, the cost to keep employees safe will continue to increase. So understanding the cost to keep your employees safe will be another critical factor when considering when to automate. Some other factors to consider. One of the obvious ones is, do I have a high volume of parts that I'm continuously encoding? Next one would be, what type of movement is in the cell? Is there a lot of manual intervention? Are the operators having to stop, change the part orientation, and then continue to spray again? And what about the parts that you might want to paint in the future? Are you designing the system with the flexibility of those parts, knowing what those parts may be? Looking at the quality requirements, does your part require a uniform thickness? Not all parts do. Some parts can have areas thicker than others, depending on how it will be used. But ensuring the part is coated the same flow rates, speeds, pressures with automation can greatly improve the uniformity of the coating. Does the end customer require verification that the part was painted according to the paint specifications? As mentioned earlier with manual viscosity checks, but if for some reason the customer would like to know the exact viscosity of the paint used to coat their part, do they have this information readily available? Or do you design the system to continuously monitor and ensure that the acceptable viscosity range is maintained? There are ways to implement this type of closed loop controls today into existing finishing applications. And what about the coating? Are you using waterborne, solvent-based, plural component? If you're using a plural component, how much time is spent measuring the correct ratios? Does it make sense to automate that step to ensure it's consistent? There are devices that control the ratios and keep the two components separate until you need to dispense. This would be for coatings with a limited pot life, so you don't need to predetermine the total volume you plan to consume each time. Does my system allow me to change colors quickly while wasting as little paint as possible? The cost of the paint itself will help determine if an automatic change valve should be added or a device that can be primed with several different color paints ready to be sprayed on demand without the need to purge or flush. Will the paint change in the future due to product or government regulations? If I'm using solvent-based, should I take this time to evaluate changing to a waterborne with all of the new VOC regulations? These are some of the examples of how the coating can impact the overall system design. Now I'm going to hand it off over to Kayla Burke from Pneu-Mech Systems to discuss some of the infrastructure considerations.
Thank you, Mike. My name is Kayla Burke and I work with Pneu-Mech Systems. Today I'll be covering finishing infrastructure considerations for automation. Today I will be covering the cost consideration, booth retrofit considerations, and your booth design. First, we'll be going over cost considerations and the operational benefits. So your first benefit will be requiring less power and less natural gas for all your air supply houses and exhaust fans. This will be because you will have about half the airflow you would have in a manual booth. To automate, you will also have a more consistent coating as well as transfer efficiency. This will reduce labor costs and improve the quality. Next, we will look at the booth retrofit considerations. It is extremely important to have a plan when looking to do a retrofit project. First, you'll start by doing a clearance study. So looking at all your dimensions, getting all your measurements, and making sure you locate all your exhaust points and discharge points as well. Once you've done your clearance study, you will look at what booth modifications have to be done as far as changing the panels or the lighting in the booth. This will in turn affect your airflow modification and your filtration. Lastly, we will cover booth design. As I mentioned previously, the airflow and filtration will change from a manual to an automatic application. With a manual application, you will have about 100 to 120 feet per minute, whereas your automatic application, you will have about 60 to 80 feet per minute. In turn, this allows slower airspeed, which in turn, you will have a smaller air supply unit, smaller exhaust fans, and a lower operating cost.
Thank you, Kayla. So now that we've gone over some of the things to consider, a lot of you may be asking yourself, what do I need to do? How do I implement a new system into my facility? And what steps should I take? So the first step you can take is request a consultation. This can be as simple as a phone call, but as the conversations progress, we may want to do an on-site visit. During this conversation, it really will be important to define the goals you're trying to achieve. You may have metrics that you are ready to focus on, which is great, but you may walk out of the conversation understanding that there's more data that you're going to need to collect over time to understand where the greatest opportunities lie. You can also talk about the estimated return on investment and the cost of ownership based on the level of automation. Do you expect to see a return in a year, 2 years, 3 years? This conversation may help you make some quick decisions, whether you want to upgrade the entire process in one project, or if you want to do a phased approach and slowly introduce automation as you go. In terms of ownership, I mentioned earlier that some of the automation equipment may require special skilled employees, such as robot engineers or control engineers. So while you may not have to hire these people in full time, you should at least understand the cost for those salaries and the service rates if you need to bring in those additional services from time to time. Lab validation. So the goal of lab validation is to try to replicate a production environment or your production environment as much as possible. This really requires physical parts to be sent to the lab. They could be actual production parts, or they could be parts that were quarantined due to quality reasons, as long as they're a good representation of the parts that will be provided or painted in the production. We also would ask for hangers so that we can use the same hanging method in our lab. And then we'll ask all parties to come and arrive on site early to help set up the system, to get an understanding of what it takes to actually interface with the equipment and see what it takes to set it up. Then we'll actually coat the parts using the production parameters, speeds, flow rates, temperatures, all of the requirements that you plan to run during production. Finally, we'll then verify the coating met the quality requirements. At the end, a final lab report will be shared for you to take back to the team, in addition to if you want to send those part backs to your quality team just to make sure everything is to spec. Once you decide to move the project forward, a Nordson engineer will be assigned to work with the key individuals assigned to the project. They will work to develop a full set of drawings, which will include a booth layout, electrical schematics, pneumatic schematics, and of course the hydraulic paint schematics. And these will all be shared for review and formal sign-off prior to shipping the equipment to your facility. One of the most critical steps is to train your team. This can be anyone from line operators, maintenance staff, to even the plant manager to start familiarizing themselves on the equipment before everything shows up. Nordson University is a structured hands-on training program that can be customized for your application. This is really intended to help the installation process and get the team starting to think about the things to prepare for. These classes are held in Amherst, Ohio on a regular basis, but can be also scheduled to fit your project schedule. We do like to have them at our facility just to give everybody an opportunity to spray the equipment and see what good looks like. But if for some reason this isn't possible, we can certainly make other arrangements to accommodate. Moving on to the installation and startup. So now that all the equipment has arrived and you're ready to install, Nordson does offer installation services to help verify the final mounting and connections prior to energizing the system. Again, depending on exactly what is involved, there may be several integrators such as Pneu-Mech and other contractors on site that will require some coordination. But once everything looks good, we'll be there to help flip the switches and make sure everything looks good. Again, referencing back to those lab test specifications that we've developed earlier. And then again, once everything is installed, you're going to want a sustainment plan, not just for service items, but you may need assistance setting up new parts or adding coatings to your lines. Nordson TrueBlue is a pre-scheduled plan designed around your specific application needs. This can be once, twice, 4 times, or whatever frequency makes sense. In addition to making sure the equipment is performing as expected, this is also an opportunity to ensure your team is continuously being trained. As your team continues to learn more about the equipment, the questions they will ask will become richer and have more meaning to them as they learn more about the equipment. Another nice thing is at the end of this visit, a formal inspection report will be given. This report will highlight any items that need immediate attention, as well as any general observations that were noticed during the visit. So in conclusion, we are here for you. We talked earlier about Nordson University being specific to your application, but if you'd just like to learn more about the different spray technologies that are out there, there are some dates we have open for people to attend in general, just to reach out and book a visit, and we'll be happy to assist.
Okay, many thanks to Mike and Kayla for today's presentation. We have a few minutes now to open the webinar up for questions. Attendees, if you have a question, please use the question field on your GoToWebinar control panel. And as a reminder, the webinar is being recorded and when complete will be made available to you via email from Products Finishing. Okay, so the first question, for combined manual and auto spray booth, what would be the airspeed requirement?
The airspeed requirement would be 100 feet per minute.
Okay. What are the steps to develop a plan for retrofitting an existing paint booth for auto application equipment?
One of the first things that's needed is a clearance study for the equipment. And not only does the equipment fit, but can you access the equipment for maintenance?
Okay, how much downtime is typical for a retrofit?
It depends on the application equipment that's being installed. If it's robotic, it could be a couple of weeks. If it's a reciprocator, it could be done potentially over a weekend.
Okay. How do the booth supplier and application supplier work together?
From our perspective at Pneu-Mech, once the team has been selected, then say, for example, Pneu-Mech and Nordson would need to meet together with the customer to go through the scope and develop a plan and a responsibility matrix.
Okay. What is the best coating application for high temp welding with PET plastics? Does anyone have an answer on that one?
That one would likely fall more on the application side of things.
Okay. Why would I choose a reciprocator over a robot?
One of the major factors to consider would be how many different part styles I have to coat. One of the downsides of using robotics is a robot path program needs to be made for every part style or part type, whereas in a reciprocator type application, we use more along the lines almost a true vision system, that we're able to map out the part and trigger the applicators on only when a part is present.
What is an acceptable line speed range for reciprocators?
For reciprocators, we can handle line speeds up to about 40 feet a minute.
Will I still need manual touch-up?
When you look at automating a line, a lot has to do with the geometry and shape of the parts that we're coating. So if the parts are pretty basic in shape and don't have many recessed areas, a lot of times we can use a conventional spray or even possibly an electrostatic sprayer to help us improve coverage. But there are parts that offer difficult geometries or deep recessed corners that sometimes may need to have a manual gun reinforcement after we apply with the automatic sprayers.
And this one is, do robots have true vision systems? I think you spoke a little bit about that. Maybe you can go a little more into that.
Yep, so that's one of the sort of the buzzwords that has been used in the automation industry over the last few years are vision systems. And unfortunately, that technology, I would say, is not fully functional in robotics at this point. Robots are, real good at doing a repetitive motion following a program that an engineer has programmed, or a path that an engineer has programmed, but they're not real good at actually, when you can send a bunch of variable parts down the line, they're not really good at detecting and automatically programming themselves to coat those parts. Sometimes they can physically detect which part style is coming down the line through a barcode scanner or something like that, and that would automatically select the proper program. But the robot technology does not exist yet to actually come up with a true paint program, a paint path program on the fly as parts are coming down the line.
Okay. I believe that is all the questions we have. I'll keep watching to see if any more come in, but many thanks to Mike and Kayla for today's presentation. And I'd like to say, just how much we appreciate you taking the time for this today. And many thanks also to our attendees for taking time to join us. We really appreciate you being here and hope you'll join us again for the next products finishing webinar. For more information, please visit pfonline.com/webinar or /webinars. And if you have any other questions, we can route those to the presenters if those come in. Thanks everyone and have a great day.